Hello. Today we are going to talk about linear equations in two variables. So we have discussed linear equations already, but the type of linear equations that we discussed in Unit 1 dealt with linear equations in one variable. And the linear equations in one variable that we did were solvable by isolating the variable. In this unit, we will talk about solving, but it comes at the end. And so we're going to start these types of linear equations talking about graphing, because that's one of the main things that we're going to do with these linear equations in two variables. So I pulled up a little note sheet here, and these linear equations that we're going to talk about graph in a line. So we'll be looking for points on this line so that we can create a nice, neat line on our coordinate plane. There are several different methods for graphing, so we're going to discuss a couple of them. The old school way that you probably have done it in the past is to make a table. That's probably one of the least time effective methods, because most of the time tables have several points in them, and technically you really only need excuse me, 2 points to make an equation of a line to make the picture. So a table, while yes, it works every time, it's probably not the best method. So in this section, we're going to discuss graphing linear equations using the x and y intercepts. So the x and y intercepts are the points where the graph crosses each axis. The x-intercept is where it touches the x-axis. The y-intercept is where it touches the y-axis. It's very easy to solve for the x and y intercepts, because all you're going to do is replace the opposite variable with 0 and solve for the remaining variable. So when we're finding the x-intercept, we make y 0, and when we're finding the y-intercept, we make x 0. So we have an example here that we're going to take a look at together. And this first example is nice and neat. It's in what's called standard form, which we'll talk about more later. Standard form is where x and y are on the same side of the equation and the number by itself is on the other side. That will come into play again later on. But we're going to do the work to find the x and y intercepts here. So we're going to start with the x-intercept. And again, to find the x-intercept, we make the y coordinate 0. So 3 times 0 plus 2x equals negative 6. Now, all this is really going to do is eliminate that variable's entire little piece from the equation altogether, leaving you with a much simpler equation, 2x equals negative 6. And then to get x by itself, we divide both sides by 2. So x is negative 3. Technically, when you find your x and y intercepts, you're going to write them as ordered pairs. So the x-intercept here, the x-intercept here is negative 3, comma 0. Negative 3 is the x-coordinate. 0 was the y-coordinate that we plugged in. We do similar work for the y-intercept. So for the y-intercept, we are going to plug in 0 for x. That will look like 3y plus 2 times 0 equals negative 6. And then we've got this piece that cancels this time, this whole chunk, leaving us with 3y equals negative 6. Again, we're trying to isolate the y, so we divide both sides by 3, and y is negative 2, which I will also write as an ordered pair. Notice we do not put the x and y intercepts together as a single ordered pair. They are separate ordered pairs, creating 2 separate points for our graph. And what's nice about that is that now we can plot these 2 points, and that's enough to make our line. So I'm going to plot here. My first one is negative 3, 0, which is negative 1, 2, 3 right here. My second one is 0, negative 2, 0, negative 2 right here. It's hard for me to make points on here because it wants to turn them into circles. And then we're going to connect with the line. Let's see if we can make a nice line here. Oh, I'm going to have to turn it a little bit. That's okay. Oh, I like playing with this thing. The whole thing needs moved. Now I can't move it. Well, you get the idea. I should have done a better job. So you connect your actual points with the line though instead. Just wanted to try to make it nice. And that's how you're going to graph with the x and y intercepts. Now, at times, they're going to give you an equation that is not in any kind of nice form. So you need to at least simplify it first, like in this case. So I'll show the simplifying, and then you guys can try the x and y intercepts. But in this case, we've got some parentheses and all kinds of variables kind of mixed around. We want to make sure that we get this thing into a nice workable form, so you at least need all the x's and all the y's combined. So I'm going to go ahead and simplify this. Distribute that negative in there. So that's 2x minus x minus y equals x plus 1. And now over here on the left, I want to combine these like terms here. 2x minus x gives me 1x minus y equals x plus 1. And then we probably should get the x's on the same side to make this thing look right. So let's subtract the x over. And that gives me negative y equals 1. Now, this is actually a special case, so let's go ahead and talk about that. You'll notice that during the course of the simplifying and solving here, we ended up completely removing the x variable out of the equation. When you have an equation that should have two variables but now only has one, this is a special case scenario. So in this scenario, you want to actually solve for that variable. So we're going to divide by negative 1. And that gives me y equals negative 1. And this is the equation of a horizontal line. The only ordered pair we have is this one right here, y equals 1. 1. Oh, I'm sorry, it's supposed to be negative 1. Might be helpful if I graph the right point here. Negative 1. And that means that we are going to have a horizontal line straight through that point. Horizontal means flat, not up and down. So let's see if I can do it better this time with a line. So we're going to draw ourselves a straight line through negative 1. A little bit better. I'm not very good at using this line tool. Horizontal lines are special. They have special slope, and they always look like this, but somewhere on this coordinate plane. So we'll talk about that again in a later section. But in a horizontal line, you're going to have a y-intercept, but no x-intercept. The only time that you would get an x-intercept is if it actually was right on the x-axis. But for the most part, you're not going to have an x-intercept. So if you want to state these, you would say x-intercept, none. Y-intercept is there at 0, negative 1. Side note, if you solve your equation and the y's cancel and the x is left, then you have a vertical line, which is kind of the opposite. You'll have an x-intercept but not a y-intercept, and it goes straight up and down. So we'll get more into that later. But for now, this is really all that we're going to talk about in this section. It's an intro talking about graphing x and y intercepts. This is another vertical line that we just went through, so we don't need, or not vertical, horizontal line, so we don't need to go back through that. You'd isolate y again. In the next section, we're actually going to get into some stuff. So I'll stop this one here and start the next one immediately to actually get into some content here. So this is it for 2-2.